Hello everyone, welcome to my channel. Finally, after a lot of ifs and buts, I've decided to post some content and probably would try to commit to posting more videos. Please forgive me if there is some unnecessary noise. I'm living in my hostel, so definitely there would be some noise. I'll try to rectify them with time. Alright, so let's go. So I'm here with the Leetcode problem of the day, February 13th. That is a day prior to the Valentine's Day. So let's see, what is it? Count odd numbers in an interval range. Given two non-negative integers, low and high, return the count of odd numbers between low and high inclusive. Pretty straightforward question. So we'll be given two numbers, low and high. We need to say how many odd numbers are there in this range, including this and this. So there is nothing like fancy we can do about this. We can just simply run a for loop from 3 to 7 by initializing a count variable, and if it's an odd number we will increment the count variable. That's it. So let's try to code this. Int count equals to 0. Please don't mind, a lot of noise is going on. For int I equals to low, I less than equals to high, equals to, because high both are inclusive, right? I plus plus. We need to return it at the end. Return count. If I modulus 2 is equal to 1, which means if it's odd, count plus plus increment. So this is pretty much our solution. Let's try to run it. Oh my god. Fine. Now if you submit, you will probably get a TLE. Why? I don't know if that's the case for other languages. Why? Because this modulus operation is quite expensive. Okay. So in order to avoid that, what we can do is we can do I and 1. What does that mean? We are doing an AND operation with the rightmost bit of the number I. Let's see. Let's take 3. What is the binary representation of 3? It's 1, 1. The rightmost bit is 1. If we do an AND operation with this, we will get 1, which means it's odd. We know it's odd, right? It's 3. Let's take 2. The rightmost bit is 0. 0 and 1 is 0. That means for an even number, we'll get a 0, and for odd number, we'll get a 1. This very simple bit manipulation concept. So yeah, if it's 1, means it's odd, simply increment. Now let's submit. This will work. There we go. 2514 milliseconds. Very, very inefficient, I would say. Is there any way we can optimize this? Yes, definitely. So that would be based on some simple observations. So let's see. Let's take this range. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is odd, this is odd, this is odd, this is odd, and this is odd. How many odd? In this range, we have 5 odd numbers. Alright. Let's take 3. How many odd numbers do we have till 3? We have this and this. What we are going to do is that if we are given a number and we know how many odd numbers we can obtain from 1 to that number, we will get it. Alright. Let's see. How many? Here we have 1 odd number. Yes. Till 2, how many we have got? 1. Till 3, 1 and 3 is odd, so 2. Till 5, 1, 3 and 5 are odd, so 3. Till 6, it's 3. 7 is another odd, so 4. Again 4. 9 is another odd, so 5. Yes, it's 5. It's 5. Okay, now the range we have been given is, say, 3 to 9. It's 3 to 7, but let's take 3 to 9. We need to find how many odd numbers are there. How many? 1, 2, 3, 4. The answer for this is 4. Let's try to observe something. If we are given 9, the answer we are getting is 5. If we are given, say, 7, the answer we are getting is 4. If we are given 6, the answer we are getting is 3. This is nothing but the ceiling value of 9 divided by 2. 9 divided by 2 is 4.5. The ceiling of 4.5 is 5. Yes, it's 5. Same for 7. 7 by 2 is 3.5. Its ceiling is 4. 6 divided by 2 is 3. Ceiling of 3 is 3. So, what can we infer from this observation? If we know the number of odd numbers till this range and the number of odd numbers till this range, why not this? Because this is also an odd number, right? We want to count this in our, like, we want to count this in. So what we will do, we will get the odd numbers till high, isn't it, minus the number of odd numbers till odds till low, sorry, low minus 1, odds till 9 minus odds till 2, isn't it? Odds till 2, odds till 9. What is the number of odd numbers till 9? It's 5. Till 2, it's 1, which is 4. Yes, it's our answer. So what we are going to do is that we are going to take the ceiling of high by 2. From that we are going to subtract the ceiling of low by 2. That would be our answer. Let's do that. Let's take a variable and high h math dot ceil. What was it? High by 2, right? Int l math dot ceil low minus 1, because we want to count that low number, right? So we will check till before low. At the end, return what? H minus l. Now we are not done. Math.ceil function returns the value in double format. Double is a data type, isn't it? Oh wait, sorry. So we are being returned a double number, right? So we need to cast that to int. Similarly for this one. Done. Now we are still not done. High by 2. This is high is an integer, 2 is an integer. We are doing integer division. If we do 5 by 2, integer division gives us 2, but it's actually 2.5, right? So we need to turn this 5 to a double. How are we going to do that? We can explicitly typecast it to double, or you can say we can multiply high to high with 1.0. So it will turn into a double. Similarly for this one. So yeah, this is pretty much our solution. Let's see. Yes, that was, see, 0 ms. This is a constant time operation. This is the time complexity of this solution is O of 1. Okay, that's why it's so fast. You can check out other people's solution as well. Like, many people have done different things, not very different, but yeah, you can check out my solution as well. I try to write as much theory as possible and try to make it clear, and maybe upvote it if you like my solution. So that's it for this video. If you like this video, make sure you hit the like button and subscribe, definitely, and maybe share this video to your fellow lead coders. And yeah, see you in the next video. Bye bye.